So we want to make it where the k is going to split the cosine. Let's first draw the parent function of the cosine. Cosine graph does something on the negative and positive pi over 2. And it looks like this. Oh, look at that pretty graph. Whoa. And that is at pi over 2 here and negative pi over 2. Do we need to know why it's crossing 0? Okay, good. I was a little worried. So then we need to figure out where can my value of k go so that we have my left side is 3 times more than the right. So let's say I take this right here. Oh, that's not even close. But let's say we have x equals k right here. We want the region on the left side of the k to be 3 times bigger than the area on the right side of the k. So the way to kind of evaluate this would be integrating from negative pi over 2 to k of our cosine function must equal 3 times a smaller one, which starts from k to pi over 2 of the same cosine function. So are we okay with the setup? Okay? So let's go ahead and find the antiderivative of this. So when I antiderive cosine, what does that give me? Sine. So we have sine of x. And we're evaluating from negative pi over 2 to k. Must be equivalent to 3 times the sine of x from k to pi over 2. So let's plug them in. So the first one I'm going to plug in is our k to the left function, sine of k, minus sine of negative pi over 2. Okay, on the right side, let's leave a 3 outside and open up a bracket. Then I have sine of pi over 2, minus sine of k. Nice. Okay, let's evaluate what pi over 2 is, or negative pi over 2. So down here is negative pi over 2. The order pair at that quadrantal is going to be 0, negative 1. And sine is opposite or adjacent movement. Sine is the opposite, so we're taking the negative 1 and subtracting it. So really in the end, I'm looking at sine of k plus 1 is equal to 3 times something. Now let's look at pi over 2 on the top right here. That is 0, 1. So sine of pi over 2 is what? 1 minus sine of k. So far, so good? Let's distribute the 3 then. We have sine of k plus 1 is equal to 3 minus 3 sine of k. And let's put all the signs together. When I move the 3 sine k, that's going to give me 4 sine of k. And let's move the 1 over. So that's going to give us what number on the other side? 3 minus 1, 2. So we know our sine of k, sine of k is equal to 1/2. So to make k by itself, it's really the inverse of sine, meaning we need to find what is the angle at that number. So let's kind of do a recall. If the opposite is 1 and hypotenuse is 2, what's going to make the adjacent force to become? Square root of 3. And the angle we're looking at is k right here. And opposite of 1 was 30 degrees. What do y'all remember that in radian? Pi over 6. And that is C. Do we need a recap of 30, 60, 90, and so on? No? Okay. Let's go on to number 7. What? Ooh. Colin, are you ready? I wonder what kids do when they're doing this. Reaching for the floor, right? Go ahead and read.
The functions of f and g are given by fx equals 2 square root of x and gx equals x minus 3. Let R be the region bounded by the x-axis in the graph of f and g. The graph of f and g intersect the first quadrant and the point 9, 6, which is the following gives the volume of the solid generated when R is revolved around the x-axis.
All right. So it looks like we have to make the circle twice at some point. Okay, I'll do my best. Let's first graph this. When graphing this, let's start with our linear functions because that's clearly a lot easier. So it says at x minus 3. So we know our y-intercept is going to be at negative 3. And we're going up 1 over 1. So really in the end, I'm going to go up to 3, 0. So my graph is going to look like this. Should be a straight line. We okay with that one? Okay. My next graph, that's a square root function. So we know the graph is going to do something in this manner. And notice I'm not really worried about exactly what's happening in between right there for a good reason. Which quadrant are we looking at to rotate around? Or which quadrant are we looking at in general? It's generated in quadrant 1. So let's shade in the graph bounded only in quadrant 1. So then we know the point that it's going to intersect is at 9, 6. So let's go down here and write out 9. And at this intersection, let's write out 3. Because something is going to happen. Now we are going to revolve around the what axis here? We're rotating about the x-axis. Are we okay with that? Yeah. Okay. Now I want you to split a vertical line at x equals 3. If I were to rotate just this figure, will it be 1 circle or 2 circles? If I just rotate this guy alone, it's going to be 1. So let's go ahead and mimic that circle right here. So my top equation is going to be y equals 2 radical x. And then the bottom one is y equals, on the x-axis, what is my y equal to? What is my y equal to right here? 0. So then let's connect our radius. Since I know I need a lot of room, I'm going to go all the way over here. For the equation for the area of a circle, if y'all remember, it was pi r squared. So what I'm going to do is kick out the pi. You need packet number 6. How was your lunch? Here you go. So we're going to integrate from 0 to 3. And it's going to be top minus the bottom. So we have 2 radical x all squared dx. Now let's look at the other piece. If I take this piece and rotate it about the x-axis, how many circles will it make? 2, because 1 on the outer circle here, inner circle here. So let's go ahead and write that or make that off over here. So my top equation is still y equals 2 radical x. The bottom one is our linear equation, which was y is equal to x minus 3. And the middle one is still y equals 0. So for this one, when I had a concentric circle, y'all remember doing big R minus small r? So let's do, it's really squared, minus r squared. Okay, so now let's fill it in. That's going to give us pi. The big radius is from top to the middle. And that's going to give us 2 radical x all squared minus, what about the little one? Isn't this a little one right here? Yes? So we have x minus 3 all squared, and then dx. Let's see if I wrote all that down. Yes. Okay, let me copy that over here as well. So we're going to kick out the pi. And this time we're integrating from 3 to 9, because 0 to 3 was just one whole circle. And we're going to integrate all of that. How about we write out 4x minus that piece. All right. Is that enough to match what we have right now? Or not yet?
No.
Okay, what is missing over here? What can I do right here?
Cancel.
Okay, cancel out the root, and can we also square the 2? So that's going to give us 4x. So if that is 4x, what does usually the constant go to? To the front? So now let's look at the choices. Are there some that matches or the one that matches? What letter? A it is.